Now that we've gone through everything in our rational expressions unit, we're going to take time to review all of it before your upcoming test. So when we started this unit, we started by simplifying our rational expressions, which are just the fractions. And to do that, we always factor. Factor everything first, get a complete factored form, and then go from there. So for 7x plus 35, I can rewrite that as 7 times x plus 5, right? Take out my GCF. And then x squared plus 5x, my GCF is x, so I have x times x plus 5. Then if something is on top and on bottom, they cancel. So x plus 5 divided by x plus 5 is just 1, it goes away. And I can't simplify 7 over x, so my final answer is 7 over x. Then we looked at multiplying these rational expressions, which is pretty much the same thing as simplifying, right? So if it's on top and on bottom, it's going to cancel, and there's nothing I can factor here. But I have x squared and then x cubed on top, so the x squared is going to take out the cubed and leave me with just an x. But then over here I have an x by itself, and that ends up canceling the x's altogether. Then I have a 5 over a 10. Well, 5 over 10 simplifies to 1/2, and so does 6 over 12. So on top I have nothing left, which means I have a 1. And on the bottom I have a 2 times 2, which is 4. So this expression simplifies to 1 over 4. Okay, dividing is similar to multiplying, except before I cross anything out, I've got to flip my second fraction and multiply by the reciprocal. So this first one is x plus 3 squared, so I'm going to rewrite that as x plus 3 times x plus 3 over 5 times, I'm going to put the 25 on top, and then I'm going to go ahead and factor 5x plus 15. If I take out my GCF of 5, I get x 5 times x plus 3. So one of my x plus 3's cancel, not both of them, because there's only one on the bottom, as well as 25 on top and 5 times 5 on the bottom are all going to cancel. So I'm left with just x plus 3, or x plus 3 over 1, which I don't have to write it if it's over 1. Then we added and subtracted. So to add and subtract fractions anywhere, you have to have a common denominator. So for this example, they're both 2p plus 7, so I can go ahead and combine. So I've got a 4p and a 3p to get 7p, and then a negative 3 and a positive 8 to get plus 5 over 2p plus 7. Look to see if you can simplify from here. I can't factor the top or the bottom, and they're not the same, so I can't cancel them out. So then my final answer stays 7p plus 5 over 2p plus 7. Always look to see if you can keep going. You want everything to be in simplest form. Subtracting is the same idea, except that you've got to remember that you're going to have to distribute this negative or deal with it some way or another before you can simplify and get your final answer. So if I'm looking for my common denominator, 2x minus 6 and 6 minus 2x, I see the exact same thing, just reversed. It's all subtraction and my terms are just reversed. That means if I wanted to rewrite the one with x in the back with x in the front, I would flip them by saying negative 2x plus 6. Then if I take out that negative, I'm left with 2x minus 6. And then my terms are the same. So we could say that my common denominator is negative 2x minus 6, which means I'm going to multiply this side by negative 1. And then negative 1 times 5 is negative 5. And then I have this minus a 3 over negative times 2x minus 6, or negative 1 times 2x minus 6. Negative 5 minus 3 is negative 8. All right, now I have a negative on top and bottom. I can go ahead and cancel those out. But I have to look to see if I can keep going. This 2x minus 6 has a common denominator. So that means I have 8 on top, and I take out that 2, and I get x minus 3. Well, 8 divided by 2 is 4. So my final answer is 4 over x minus 3. All right, to solve, I want to find my common denominator, and then once I get everything to have the common denominator, I can cancel out the denominator altogether. But you have to keep in mind the numbers that would be extraneous, the ones that you would make your equation divide by 0, which we can never do. If I get that as a solution, it is an extraneous solution. So to start with, if I'm going to go ahead and factor everything, 2x is simplified, x plus 1 is simplified, and then 3x squared plus 3x is going to be 3x times x plus 1. So my common denominator is definitely going to have an x plus 1 in it. So take care of these two. So we're going to have an x plus 1. Definitely going to have an x, because we got the x's in two of our terms. And then I've got this 2 and 3. Well, 2 and 3 don't go into each other, so a number that they both go into is 6. So my common denominator is 6x times x plus 1, and everything can go into 6x times x plus 1. So the 2x is missing the 3 to get to 6 and the x plus 1. So I'm going to multiply this one times 3 times x plus 1. The x plus 1 is missing the 6x. And then the 3x times x plus 1 is just missing 2 to get it from 3 to 6. Okay, and then I don't need my denominator anymore. We can get rid of this. So now, 1 times 3 times x plus 1 is 3x plus 3. Negative 1 times 6x is negative 6x. And then 1 times 2 is 2. 3x minus 6x is negative 3x. Subtract my 3 over, and I get negative 1. Divide by negative 3, and I get x equals 1/3. Now we have to make sure it's not extraneous. I'm going to come back to my original equation. To make 2 times x 0, x would have to be 0. So that means that x can't be 0, or I would have an undefined term. To make x plus 1 0, I would need a negative 1. And then to make 3x times x plus 1 0, I either need 0 or negative 1, but we've already accounted for those. So that means that I can solve, and as long as I don't have a 0 or negative 1, my answer is okay. Well, I got 1/3, which is not 0 or negative 1, so 1/3 is my answer. Then we graphed reciprocal functions. So remember the reciprocal function's the one that's our hyperbola, where we're in quadrants 1 and 3. And then we have our a, h, and k. So if I look at this one, my a is 3. So that tells me that it's stretched by 3. And because it's positive, I know that I'm still going to be in quadrants 1 and 3. This plus 2 is really a negative 2, and that's my h value. So that means that I'm taking my graph and going left 2. My hk point is negative 2, 0. So that's where my asymptotes intersect. So I'm going to go negative 2, 0, and put my dotted lines. I know I'm in quadrants 1 and 3. So there's my graph, or there's a sketch of my graph. The domain and the range, you just skip over your asymptote. So if I'm looking at my domain, I skip over negative 2. And asymptotes always get parentheses, and then I jump negative 2 to infinity. And my range, my horizontal asymptote is 0, so I'm going to do the same thing but jump over 0. For our rational functions, we have to be able to find 4 things, and then we'll kind of use our calculator to do all the sketching. So for the first one we have to find, that's our x-intercept. So our cheat for finding the x-intercept, right, is to plug in 0 for y. Well, when I do that, I'm going to end up setting the numerator equal to 0. Right, so for this one over here, we've got quadratic, so we're going to go in a factor just to make our life easier, just so that we can see it in a different way. So to multiply to negative 5, add to 4, that's going to be a positive 5 and negative 1. And at the bottom, multiply to 20, add to 9, that's a positive 5 and a positive 4. Now, once I factor this, I notice that the x plus 5s cancel. So when I come down here, my new equation is x minus 1 over x plus 4. I'm going to graph this and answer all my questions based on this new equation, but I can't forget about that x plus 5. We'll come back to that in a minute. So now to set my numerator equal to 0, I got x minus 1 equals 0, so that means that my x-intercept is at 1, 0. If I come over here, I'm going to go ahead and factor the bottom, so I'm going to take out that negative 4, and then we get x plus 4 because I took out a negative, so it changes my sign, so nothing cancels. Set my numerator equal to 0, and I get x is 4. So my x-intercept for this graph is 4, 0. To find the y-intercept, we're going to plug in 0 for x. And when we do that, we end up looking at our constants. So whatever our constants are, because anything that has an x in it will go away, because anything times 0 is 0. So we divide our constants. So for this one, my y-intercept ends up being negative 1 over 4. So 0, negative 1/4. And over here, I have a negative 4 over a negative 16, which again is positive 1/4. So I have 0, 1/4. Then you want to look at your vertical and horizontal asymptotes. So the vertical asymptotes we can't divide by 0. So now we're going to set the denominator equal to 0. Alright, so in this case I have x plus 4, so that means that my vertical asymptote, the equation for it, is going to be x equals -4. Alright, over here, if I look at the factored form, the only one I care about is the x plus 4, so again, my asymptote is at x equals -4. And then our horizontal asymptote, we go to Bobo. So we have Bobo, Bottom, Spud. Alright, so for Bobo, Bottom, Spud, it's bigger on bottom, it's 0. Bigger on top, there is none, but there's oblique. And then same power you divide. So if I look at my first one, I have x to the first over x to the first. So that is same power you divide. Well, my coefficients are both 1. 1 divided by 1 is just 1. So my horizontal asymptote is at y equals 1. Over here, I have x to the first over x to the first. Again, same power you divide. So I get 1 divided by -4, which is just -1/4. So my horizontal asymptote is at -1/4. Now if I come back to this one over the first one, remember we crossed out that x plus 5. I still have part of my graph that's undefined at -5, because if I plugged in -5 to my original equation, I would get an undefined. I have a 0 on the bottom. So because even though it cancels out, I don't have an asymptote at -5, but I have that hole at -5. So here, I have a hole at x equals -5. So that means whenever I go to graph it, wherever my line is or my curve is at -5, I literally just put a hole. Because we jump over that point, it's just not an asymptote. It's not something the graph approaches. It literally just jumps over. Alright, and then again, if I had no horizontal asymptote, that means I have an oblique asymptote. And to do that, we divide and ignore the remainder. Right, so if it was bigger on top, that means I would take the top divided by the bottom, doing long division or synthetic division, and ignore whatever the remainder is. And the equation I get is my oblique asymptote. We also looked at rational inequalities. So for rational inequalities, we got to make sure, one, it's all in relation to 0. 0 has to be on one side, because then we can look at our positives and our negatives. And we also need to make sure we have one fraction. So I'm going to have to combine this 3x plus 1 over x plus 4 with this -1 over 1. So to do that, find a common denominator, which is x plus 4, so I need to multiply it by x plus 4. So I get 3x plus 1 minus x minus 4, because I've got a negative to simplify. Alright, 3x minus x is 2x, 1 minus 4, -3, over x plus 4, greater than or equal to 0. Then from here, I need to get my critical value. So for the top, what x value would make it 0? I'm going to add my 3, divide by 2, so it's 3/2. So one of my critical values is 3/2. And then my other one makes the denominator 0, which would be a -4. So now I have 3 sections that I'm going to test to see which ones are going to give me positives, because I want this to be greater than or equal to 0. So something less than -4 is -5. Well, 2 times -5 is -10, minus 3 is still a negative, and then -5 plus 4 is a negative. So that means this section, because I have 2 negatives, it's going to be positive overall. Between -4 and 3/2 is 0, so 2 times 0 minus 3 is negative. 0 plus 4 is positive, so that section is negative. And then we can say 2. 2 times 2 is 4, minus 3 is positive. 2 plus 4 is positive. I want the ones that are above 0, so I'm going to go to the left and to the right, write an interval notation. So I have -infinity to -4 with a parentheses, because that's going to make my bottom 0. And then I jump with a bracket from 3/2 to positive infinity. And then the last thing we looked at were inverses. So to find the inverse, you switch x and y and solve for y. So we have x equals 3y plus 2 over y minus 1. Got to multiply by y minus 1 to get it out of the bottom. So then I have xy minus x equals 3y plus 2. I want my y's on the same side, and then the x on the other side. Take out my GCF. And then to get y by itself, we just divide. So my inverse is x plus 2 over x minus 3. Switch x and y, solve for y.